Alright, this video is on identifying conics. Alright, so when equations are in standard format, there are still ways to tell which kind of conic it is. Alright, so here's your basic equation for a circle. How is it different from the other four equations? Well, for one thing, there are no fractions. There's no fractions. As you can see, ellipse and hyperbola, there's fractions. There's not fractions for a parabola either, but what also differentiates it is this plus sign. Alright, so when you're looking at an equation and you're trying to figure out which conic it is, if you have no fractions and they're added together, you know that that's going to be a circle. Also, this equals your radius squared. Okay, that equals your radius squared. Now with an ellipse, you notice you do have the fractions. Right? You do have fractions. This is also plus. And remember, an ellipse will always equal 1. Alright? So remember, a circle, there's no fractions. No fractions. They're added together, and it's always going to equal r squared. For an ellipse, you'll have fractions. They're going to be added together as well, and it will always equal 1. For a hyperbola, alright, again, you have fractions. But the key thing that differentiates hyperbola from ellipse is this is a minus sign. Alright? And again, this will always equal 1 as well. And then for a parabola, you only have one term squared. One term squared. Alright, so these probably aren't the ones that are going to be that difficult. Okay? Because if you remember the standard, as long as you remember your standard form for your equations, this really isn't that difficult, identifying them when they're in this standard format. Alright? But what if it's not in one of these standard formats? What do I mean by that? Well, let's look. Alright, what if it's not in standard format? For instance, say we have 3x squared minus 7x plus 3y squared plus 9y minus 12 equals 0. Or say we have 4x squared plus 10x plus 9y squared minus 5y plus 6 equals 0. Or 6x squared plus 12x minus 4y squared plus 8y minus 10 equals 0. And our last one, 8x squared plus 14x minus 10y plus 6 equals 0. Alright, so these are in non-standard format. Alright, so how are we going to figure out what kind of conic we have when they're in non-standard format? Well, there's a few things to look for. Alright, this first one here, I'm going to go ahead and tell you what it is, and then I'm going to tell you what to look for. This first one is going to be a circle. And here's what you look for a circle. You want to look for two squared terms that have the exact same coefficient. Okay? So, 2 squared terms, same coefficient. Alright? So you have x squared and y squared, and they both have the same coefficient of 3. Alright, so 2 squared, same coefficient, you know it's going to be a circle. Alright, now this next one here is an ellipse. Here's what to look for. You also want to look for two squared terms. Okay? So here's one, here's one. Two squared terms, different coefficients, but the same sign. Alright? Same coefficient, different coefficients, but same signs. Alright? Because that's the only thing that's going to differentiate your circle from your ellipse. Here you have the exact same coefficients. Here they have the same sign, so they're both positive, but they're actual different numbers. So this is positive 4, that's positive 9. That's what differentiates a circle from an ellipse, is yes, they still have the same sign, but they're different numbers. Okay, they're different numbers. Now this one's a hyperbola. You spell that right. Now, what to look for with a parabola? Two squared terms, okay, because as you can see, there's still two squared terms. So two squared terms and different signs. Alright, so we have two squared terms. This one's positive, this one's negative. That means we have a parabola. It doesn't matter what the numbers are, as long as they have different signs, okay, and it's different and it's on the squared term. So this is negative 4y squared, positive 6x squared, two squared terms, different signs, hyperbola. All right, two squared terms, different sides, hyperbola. Now the last one here is a parabola. Parabola is easy, just look at it. What's different about it than the previous three? Hopefully you said only one squared term. Only one squared term. So when they're in non-standard form, that's what you want to look for. Look for how many squared terms you have. If you only have one, parabola. Doesn't matter what the rest of it is. If you only have one squared term, you have a parabola. If you have two squared terms, you know it's not a parabola, but now we have to determine whether it's a circle, ellipse, or hyperbola. Alright? Well, if the squared terms have the exact same coefficient, that means you have a circle. If they have different coefficients, but they both have the same sign, so they're both positive or they're both negative, you have an ellipse. And if you have two squared terms that have different signs, this one's positive, this one's negative. Okay? Now, the x could be the negative one and the y could be the positive one. That's fine, they still have different signs. So, same, when you have two squared terms, coefficients are the same, circle, different but same sign, ellipse, opposite signs, hyperbola. Alright, you want one of each. One has to be positive, one has to be negative for it to be a hyperbola. And then again, parabola, you only have one squared term. And then don't forget what we went over on the previous board. That was just basically recognizing what type of conic you had from your standard form. And remember, your standard form was the equations that I gave you on that sheet. Alright? Just remember, a circle, you have a plus sign and no fractions. An ellipse, you have fractions, a plus sign, and it always equals 1. Hyperbola, you have fractions, a minus sign, and they always equal 1. And for hyperbola, you only have one squared term. Alright? So, it's kind of a shorter video. Well, it's 10 minutes long, but... So, you can watch this as many times as you need to, and when you come to class tomorrow, be ready to identify some conics. See you tomorrow.